Okay, so we're trying to graph simple rational functions, okay? Now, in the first question, you're asked to find the zeros of this function. That's a rational function, by the way. And we need to find the zeros, and then the y-intercept, and then we need to find what kind of discontinuity, okay? And to do that, we're going to be finding the limit of the function. This is to find the asymptotes, all right? Now, the first thing we want to do is, I guess we are asked to find the zeros of the function. So to find the zero, that means what are the values for which the function is crossing the x-axis? This is the x-axis. This is the x-axis. So when you are asked to find the zeros of a function, you're trying to find the point for which the function is crossing the x-axis.
Right.
Okay. So to do that, we're gonna first write down the function, and then we're gonna set it equal to 0. Okay. So that means where is the function crossing the x-axis? And then we're gonna solve for x. All right. So the first thing I want to do is I'm gonna add 1, and stop me if you're not getting something.
Yeah, wait. So right here. So we're doing the same thing of what we're doing with like how we use this equation to find where it is, right?
Where to find the values for which the function is crossing the x-axis. All right. So we have 1 over x plus 2 equals to 1. Okay. Now what do I do from here? Remember what we did last week? The
with the
cross.
we put 2.
No, we don't do that. We
Cross multiply.
Cross multiply, right? 1 times 1 is
1.
and then x plus 2 times 1 is x plus 2. Okay. And then from here I can solve for x. I'm gonna do what? Subtract.
Well, subtract 2 on both sides.
And I'm gonna be left with 1 minus 2 equals
negative 1.
Negative 1 equals to x. Okay.
So that's the word 0.
That's the only 0. This function only has 1 0. So that means this function is gonna cross the x-axis only once. When x is 1, that means when x is 1, y is gonna be 0. Okay.
So if there's only one thing that goes by, y will be 0.
Yeah. When x is negative 1, y is going to be 0. That means this is where you're going to cross the x-axis, right? Now to find the y-intercept. Y-intercept is basically the same process, but now we want to find the values for which the function is crossing the y-axis. Okay?
Yeah.
So the y-intercept is the values for which the function is crossing the y-axis. So to do that, we're going to set y equal to 0 and solve for, no, we're going to set x equal to 0 and solve for y. Okay? So basically what I'm doing is I'm finding f of 0, meaning I'm replacing x by 0 to find y.
So anything that's x, you plug in 0.
0. There you go. So it's going to be like this: 1, 0 plus 2 minus 1.
And then
right?
You do the same thing with cross multiply.
You don't do the cross multiplication because we're just 0 plus 2 is what?
No, 0, 2.
2. So you do 1/2 minus 1, right? Now we need to find a common denominator. Okay, we don't have, you can use your calculator, but it's better to do just find the common denominator, right? This is like 1 over 1. So the common denominator is 2. Now you see, we are doing algebra again. That's why it's good to know this thing. So the common denominator is going to be 2. So to get 2, I'm going to multiply this one by 2 and this by 2, correct? So I get 1/2 minus 2 over 2, right? So it's 1 minus 2 over 2, which is negative 1 over 2, right? So my y-intercept is negative 1/2, all right? So when y is equal to negative 1/2, x is 0. Now you have your 2 points, right? So we have x and y. When y is 0, x is negative 1. And then when x is 0, y is negative 1/2. Okay? Now they want to know the location and discontinuity. Okay? So to find that, we need to find the domain of the function. Basically, we want to know the values for which the function is defined. Okay? Remember, we worked on something similar when we were working with piecewise function. That was 2 weeks ago, right? So look at this function here. F of x is 1 over x plus 2 minus 1, right? So I don't want this to be equal to 0. Do you know why?
Because you want to see if it has a discontinuity.
Exactly. Because 1 over 0 is undefined, right? So
you need to find the limit.
The limit first, but we need to find the domain of the function. So we don't want x plus 2 to be equal to 0.
So
right?
how do you change it?
So we don't want that, right?
Mm-hmm.
So we're doing the same thing. So we don't want x to be equal to negative 2, right? So when x is negative 2, the function will be undefined. So this will be a vertical asymptote, meaning you don't want x to be equal to negative 2. At that moment, there will be discontinuity because the function cannot touch this. This will be a limit.
When it's a vertical asymptote, it's discontinuity. I can't say words right now.
Discontinuity, right? So that means x equals negative 2 will be, we call it a VA, or vertical asymptote, right?
Mm-hmm.
Now we can find the limit of these functions, all right? So as x approaches negative infinity, right? We're gonna replace, remember what we did it last week or 2 weeks ago?
Mm-hmm.
Plus 2 minus 1, right? As this approaches negative infinity, what's gonna happen?
Oh, hold on. There's a graph. I remember.
1 over infinity.
So when it's infinity is going like this.
It's gonna be when you approaches. No, don't worry about it. Look, let's look at it, right? Replace this number here by the biggest number you can think of in the negative side.
Negative a million.
Negative a million, right? If you do 1 over negative a million, what are you gonna get?
1. No, negative a million.
You're gonna get 0. Something close to 0.
Wait, why?
Okay, what's 1 over a million? 0 point what? 0, 0, 0, 0, 0, 0, 0. How close is that to 0?
To like 0.9.
No. Can you divide one? Take one biscuit and try to divide it into 1 million people.
You can't.
What are you gonna get?
Cream.
Nothing, basically.
Yeah.
So as x approaches negative infinity, this is gonna be getting closer to 0.
So it's gonna get smaller.
Smaller. So therefore, you're gonna have negative 1 left. The limit will be negative 1.
Oh, because that's the smallest thing you can get on
this one here will get close to 0, right?
Mm-hmm.
Because 1 over x plus 2 will tend to go close to 0. The negative. So therefore, all you have left is, what is 0 next to negative 1? Nothing. So all you're gonna have left is negative 1. You see what I mean?
Yeah. So that'll be your limit.
Yeah, your limit will be negative 1, and then from there you can graph your function. All right. So now to graph the function, first we need to graph the vertical asymptote, right?
Mm-hmm.
This negative 1, what was our vertical asymptote? Negative 2, right? So negative 2 will be our vertical asymptote here, right? And then we have how many zeros?
1, 0.
You have negative 1 half, right?
Mm-hmm.
Actually, no, negative 1. And then we also have 0 and negative 1 half for, this will be the function here, right?
Mm-hmm.
And then we can find some other point. So you can end it up like, see, we have every piece of information that we need, right?
Mm-hmm.
We have negative 1 and 0 for the zeros, 0 and negative 1 half for our y-intercept. We have x equals negative 2 as our vertical asymptote. And as x approaches negative infinity, we have negative 1 and say the same thing for infinity, right? Now, on this portion, we've graphed our vertical asymptote, and then we have our horizontal asymptote, right? And the function is going to look like this, what we have here, this curve. You see it?
Yeah.
That makes sense now?
Like it doesn't touch it.
It doesn't touch the asymptote. That's discontinuity there.
So what we're trying to do is find the 2 points, like these 2 points.
Yeah.
So that's what we want to find. And then we have to do here.
Yeah.
But this stuff is only to determine this stuff, right?
To see how the function is behaving. Okay? And most likely you're gonna have something here and you're gonna have something here too, like this on the bottom, right? Because this is a simple rational function.
It'll reflect.
Right? It will reflect exactly. Right?
Yeah.
All right. It's a little different from the last one. The last one had a integer as a numerator, right?
Mm-hmm.
And this one, we went through the same process, found the zeros, found the y-intercept, we found the vertical asymptote, and now we're trying to find the limit as x approaches negative infinity of the function. Now, if you see here, there's a difference, right?
Yeah.
Here, you have x plus 4 and then x minus 3. The easiest way to learn this is this. The highest degree of the polynomial that's up on the numerator is 1, right? And the highest degree of the polynomial that's in the denominator is 1 as well. So what you do is this. You have x plus 4 and x minus 3, right?
Yeah.
Disregard the integers, 4 and negative 3. Disregard them.
So
Okay?
don't care about
Don't care about that at this moment. So what you do is this. Divide x over x, right? You get what?
X.
X over x gives you...
X.
No. But x over x gives you what? What's 1 over 1?
Oh, is it 1?
What's 2 over 2?
2.
What's 2 over 2?
2 over 2 is
1.
Oh, yeah.
You're thinking too hard again. What's x over x?
X.
1.
Yo, 1.
Why?
But x is 1, right?
X over x is
1.
1. That's it.
Yeah.
Okay. Now, to find the limit of this function, right? You're doing this. Limit as x approaches infinity, negative infinity, right?
Mm-hmm.
Of x over x, right?
Mm-hmm.
Which is 1. Meaning, no matter how
far you
go,
it'll
it's always be 1.
So that'll be the limit.
That will be your horizontal asymptote.
So for this,
y equals 1.
For this, the first one, it'll be y equals 1.
1. The same thing.
Whatever.
Yeah. Go ahead. I'm listening.
Because whatever you do, all right. Wait, let me try to explain this to myself when I'm looking at it.
Okay.
So anytime anytime you just disregard this.
The integers.
Yeah, the integer 1, especially if it looks like this. But for something like this, this will always be the limit.
Right.
So any number, the whole number here will be the limit.
The limit, yeah.
But if not, you disregard them and it'll be 1.
Not always 1, because if this was like this, let me write down function here, like 2x plus 5 over 3x minus 1. Disregard these integers, right?
Mm-hmm.
Just take these two here, okay?
And you'd have to do those. You'd have to do 2 over 3.
2. So what's 2x over 3x? Just look. This will go away, right?
Yeah.
What you left with?
2 over 3.
2/3.
2/3. Yeah.
Same thing.
All right.
No matter where you go, infinity is always going to be 2/3 for this function.
So it's just a matter of trying to make the x's go away.
Away. Well, basically, you take the highest degree, okay? And this is what happens most of the time. That makes sense?
Yeah.